Though, yeah. So with the linear actuators, those you can see here the saber tooths are mentioned. We will need to use the saber tooths from last year to implement them. So it would be a lot more convenient to have like same of like the brushless motors that we're putting on like drivetrain and stuff. But we'll have to see on what sort of we're leaning towards with deposition. Okay. Once. Right. So for at least before like the start of like the semester, Alex found some like really nice connectors that are pretty much just like plug and remove, which I am very interested in trying to use. So that way we can pretty much just have like the P&H box have a set outlet on like let's say I don't know just the scaffolding for drivetrain, which it just sit it down and it's latched on. But we do also have to take in consideration where everything is because I don't know if we have like a general layout of just how big like the excavation is going to be versus like how big deposition is. Preferably, it'd be more in a central location just so we don't have to cross wires. But if anything, we can try to like route them through like the little channels and the struts and everything. If there's space for that, which yeah, that would be quite nice. Yes. Okay. Yes. Yeah. Yeah. So that would also go through that whole board theoretically if we had it. So yeah. Uh, yes. That's more of a software question yet, but yeah, no. Yeah. So yeah, we were gonna have a USB bus built into it. Yeah. Yes. Mhm. That's gonna be on the yeah power distribution board in the corner over there. Yeah, it's gonna have all of our like step up, step down. Like it's gonna make sure everything's like at its proper voltage values. Right. Yeah, so the brushless motors, those have motor controllers built into them. We purely just have to provide the power wiring to them and the signal wiring, and it's like just plug and play. So pretty good. Um, hmm. All right. Any more questions? Yep. Yes. That is more of just like a general safety thing. I feel like we're gonna be a lot better about not having very long hours in the BIDC. Hopefully, with you know, we'll see. But what I would say is wait, what? Okay. No, I'm just laughing. Okay. But anyways, yeah, that could be an option that we look into. Also depends on where the box ends up being relative to everything else. Because, for example, when we had it like last year was like right at the edge of the whole like excavation cycle. I don't think that the battery would be very happy in that place. It's not a friendly environment. Not inviting enough. But yes. Mhm. Yeah, yeah. Especially if it's not like in the center and it's like mounted on the side. Yeah. Okay. Yes. So honestly, most of this stuff would be like custom except for like the Jetson and the Sabertooths and the power meter and the e-stop.
Very possible that we might combine some of these things.
Yeah.
Like protocol translation, what might be on the teaching board.
Yeah. So it's just like integrated into it. Question? Mhm. On. Yeah. Yeah, so the things we're looking for it to do is like, for example, if it's overcharged, it'll like safely be able to discharge it, and it make sure that like it's not inactive for a long period of time and stuff like that. So, mhm. Yeah, yeah. So pretty much, it should be have a connection to like the e-stop to just cut the circuit, because pretty much the way this works, it just fully just goes through that e-stop. If that's cut, nothing's gonna flow through. And it's gonna maintain that like battery health at the same level. Yes.
On that note, how difficult would it be to wire like an LED into like right next to the power meter? So it's a very visual indicator of whether or not the battery.
Yeah, that'd be pretty easy to do. I think. Yeah, it's just LED. Yes. Mhm. Mm. Yeah. All right. I actually like
That's
that.
easy enough to just stick on the teensy board.
Yeah. Okay. Yeah, I'd actually really like that. Okay. That's a good idea. Thank you, Alex. Yeah. So, just for the people on the stream, that was like adding LED lights on the actual box, so to indicate autonomy and stuff. Yeah. Yes. Um, it's definitely something we might want to look into, depending on where the box is. So, yeah. Right. Going once, twice. Sold. All right. Thank you. Thank you. Check the ball, guys. Okay. Here you go, Monsieur.
This is yours first. I think your slides are first. Okay. Hi. Ready? Make sure you hold it up to your mouth. Yep. Ready?
Okay. So to start off, we did a system architecture just so people who are unfamiliar can get familiar with sort of what we have for the overall autonomy stack. So you see at the top left is our cameras, right? From those, we get both our April tags and our SLAM. Um, Using the sort of April tag information, right, that gives us our position within the field. We mostly start on our behavior cycle, which can, like when it decides, right, publish a goal, which we can plan to and follow. Or if we're not doing traversal, if we're doing one of the other things, we go to, it's called right now behavior modules, but basically just the excavation or deposition control. And both of those things can publish linear angular velocities as well as motor commands.
Keep moving the microphone a little closer to your mouth.
Okay. Yeah, and linear and angular velocities are also translated into motor commands. At the very end, those motor commands are obviously sent to firmware. And as you can see from firmware, we also get back sensor data. And that's the overall configuration of how the autonomy stack sort of works on our robot. So next thing we'll be going over is sort of some of the things that we're looking at changing basically for this year. So first up is path following. In the past, we've used model predictive controller, right? It has been super successful up to this point. The goals we're looking at is making it consistent, obviously accurate, and more continuous. So where previously the controller sort of jumped around in a jerky manner, we wanted to follow a path as smoothly as possible, if that's possible. And we've come up with a few ideas so far. One is improving the model for MPC with real data. So one of the problems why it doesn't work right now is because driving on sand is different from a sort of really basic kinematic model that we're using right now. And so hopefully with a lot of data that we've acquired, especially from competition, like you can see there, we might be able to make a pretty good approximation of driving on sand. And we can use that and see how MPC will respond to it. A different option is pure pursuit, which is shown on the right in the animation. That's where a robot basically is trying to follow a point on the path that's a certain distance ahead. And it's a little bit different from MPC, but it's something we're definitely considering. The last option is something even simpler. I just calling it turn and drive. It would just involve turning to the next point, driving to it, obviously controlled so we can account for real world factors. The goal is whichever one works best, right? We're going to try and make all of them. We're going to test them. Whichever one works best is what we plan on using, obviously. So for SLAM, the things we want to change or improve are crater detection and the sort of field of view we have. So the way we're planning on doing this is using a second depth camera or possibly a LiDAR. And what we want to do is basically get two different angles. Like you see on the left, there's one facing sort of parallel, which is what we have right now. But I'm also thinking it could be useful to have one pointing more directly at the ground, such that we can have a much better view of craters and get a sense of their depth. Obviously, the positions of the cameras will change based on what the robot actually looks like, but this is just an example. The next thing that'll be different is that we want to avoid using the overhead cameras at NASA or UCF because those are a sort of large point loss. So something I was inspired by were the other robots at competition that had lots of little USB webcams for situational awareness, right? And my idea is that we can use them to cover basically any needed point of view we want, such that we don't need any overhead views of the robot while operating in competition, whether it's autonomous or not. On the left is obviously some examples of what the POV looks like and how the cameras could be implemented. One of the last things we're changing is that April tags. This is a small rule change. Basically, we can't have the markers in the berm area. And so I was thinking we might need to develop sort of new larger tags, sort of how Alabama did in that picture, in the starting zone corner. Basically, we need something that can be detected from farther away such that we are able to get the most correct absolute position orientation when we want it, right? But there's also a trade-off of how big can they be / how heavy can they be versus how far we can see, basically.
All right. On the firmware side, talk about new motors all day. We have to make some changes to that too. These motors are actually very easy to communicate with. They use a protocol called RS485. And in fact, we can just ask them to do things and they say, okay, and we can ask them for data and they say, okay, here you go. We have more precise control over them than we did before. We can ask them to go to any specific position, any specific velocity in the range of, I believe, minus 5,000 to positive 5,000 RPM. And we can ask them to go at a specific torque as well, which is interesting. We also have precise readings. We can read current, voltage, speed, position, temperature, and I think other things. The data sheet is very long. That is a screenshot of the motor that we've been talking about. The thing on top is the controller. The thing on the bottom is the motor. And the screenshot is a photo of the code that we currently have to go and control the motors. Yeah. In general, the thing that we're trying to do is just make everything more robust and more reliable. Things need to work all the time, every time. For those of you who weren't in the software control room, things broke every once in a while. There's things that only turned on half the time, and we just had to turn them off and try again. To that end, we're doing wired controllers, which will help a lot because sometimes a controller just doesn't connect. So having wired controllers will make that not a thing. Motors replacing a lot of sensors will help with that. So we only have the motor's the only thing that needs to work instead of motors and encoders and current sensors and everything else. A better path follower will help a lot with that. That'll make it just more robust and better able to follow the path. And we also just have a bigger software team this year, and more people just means more testing. So that'll help. And that is everything. Any questions? And that was just for those who are not in the person. That was just a list of things we should try with our models and things that may or may not work well. The rules have not changed since last year. The wheels, the rules haven't. The wheels will. Peter?
Go back to where you had the cameras, so with the robot, so you'll have two depth cameras, one facing forward, one facing backwards.
Maybe. We're unclear.
Unclear? Okay. Would the robot be traversing forwards or backwards?
Yeah, I was just gonna say it depends on like if we're doing like bulldozer, for example, then primarily all traversal we're going to be doing is probably forward. So that's where we will want like the majority of the cameras and awareness we have, right? If we have sort of a X depth back and forward, then we would want the cameras on either side because we sort of alternate between going forward and going backwards.
Wait, also one more thing on that. If we're finding an April tag that's on a wall at the beginning, we will be pointing at the April tag, which is at the wall, which means that our robot will be pointing at the wall, which means that the easiest way for us to get out is just to traverse backwards. So.
And then second question related to that, will the robot still be spinning in a circle at the beginning?
The question was, will the robot be spinning in a circle at the beginning? And I think the answer is yes.
So the situational awareness cameras can also see April tags. So if we have good enough coverage horizontally, we won't need to spin the full circle. However, it also helps create a better map at the very beginning, which is also useful. Probably yes.
So we currently have an RP lidar A2. We have it, which means that it's I think it's like an $80 lidar, but we currently have that one. It's a 2D lidar, so it only shoots in a single plane. There is about a $500 lidar from, I'm forgetting the company, but that would be a 3D lidar, which means that it is effectively very similar to our cameras in what it can see, except it just gives us distances instead of colors and images. Yes. Yeah. So basically, this front camera, you can't see what I'm pointing at, but the front camera that's pointing downwards would be replaced. What might be replaced with one of those lidars, so we can just see into craters. Yeah, if the lidar and camera give us different results for SLAM, I don't know.
Probably whether we use two cameras or a camera and lidar, we have them pointing different directions, and so we sort of are combining the data, not really like overlapping it. And as for the exact process of how it's done, it is mostly determined by the sort of algorithm, the open source algorithm we're using already. We are not going to like make any custom modifications probably.
We don't know why NASA got rid of it, but we know that in the rulebook it states you may place April tags anywhere within the starting zone along the walls, and then makes no mention of the deposition zone. So they don't say you can't, but they don't say you can either, which to me implies that, yeah. So my best guess is that they say no, you don't need that anymore. Ashwin? Okay. Yes. So, okay. Yeah. So more on like the sensor thing, you would just give the algorithm all of the different sensors, and it would go and deal with it. We don't have any data on how lighters perform in general at all. Period. We have as far as I'm aware, we have never used ours. I do know that there are teams who do use them with success at competition. We will see. But yeah, I know that there are teams who use lighter at competition. I know that I would assume it worked well enough for them because they made it to KSC. Are we planning to use the same Jetson? Yes. Unless it blows up or dies, but I don't. Yes. Hans?
So the circle you see sort of drawn around the points on the path, the center of the circle is the robot. The circle is a look ahead distance. So it's looking ahead by that many meters or whatever, right? For the intersections of the path, right? And it's going to pick the intersection of that circle with the path as the sort of point to follow. And it essentially adjusts its velocities, right? Turning and going based on how it can get to that point on the intersection of the look ahead circle. And there's more nuance to it, but that's the big idea. Can you speak a little louder? So right now, the April tags, like position-wise, it seems very accurate. The only problem we might have is drift over time, which we don't have enough data to be sure on yet. But for like a once in the moment, like where are we in relative to the April tag, the module for processing we're using seems very accurate. In general, my ideas was for the direction in which we will be traversing forwards the most. We want the sensor pointed angled down at the ground so we can detect new craters and rocks. And if we are also going backwards, then that would be the sensor that's sort of more flat to the ground, possibly.
What makes us think we can do MPC better? I think one of the bigger things is we have a lot more data in actual regolith now. We have all of the competition bags last year, and they're just available for us. So I think that the biggest thing would be processing that data and just turning it into a more accurate model instead of trying to guess at what the properties of regolith are. We know them now. I mean, other than that, that's also why we're pursuing a bunch of different things because, yeah, we're not sure if we can make it better, but we're pretty sure that at least one of these will be better. Any other questions? Right. In that case, then we will hand it off to whoever's next. Systems. Right.
Okay, so the first thing we want to present for systems is the integration plan and risk assessment. This is something we've prepared on the systems team to help make sure when we are putting the robot together, there are no integration threats or any sort of conflicts between parts from different sub-teams, right? So the key integration threats we've identified, and these are pretty standard ones that NASA uses for their integration plans, is miscommunication, lost non-existent documentation, misinterpreting requirements, forgetting deadlines, mismanaging resources, shifting focus with different revisions, roadblocks and design issues. So as part of our integration plan, which I'm just summarizing here, but you can find the full document in the systems folder of the drive, we've identified strategies for mitigating these threats to integration. So again, you can find those in the assessment, and we will do reports on them. But the general advice is that recognizing there will always be setbacks in the design process, holding frequent discussions and communication between subteams, and scheduling everything in advance so you have time to focus on integration and not just designing things for your own team. So next, Lily is going to talk about the next review.
Perfect. So the next part in our process is PDR, which is the preliminary design review. The purpose of PDR is to make sure that once we have that initial design, it still aligns with all of our system requirements without posing major integration issues like what Grant just talked about, and it's within our cost and schedule. PDR will be on November 11th from 10 to 3. We do not have a location yet, but that will be updated, probably sent out in Discord when it is. I mentioned review trackers earlier. They are still in the same place in Drive. PDR should also be there. For PDR, we do have things that we need to get ready for that so we can make sure everything goes smoothly. This is what you will see in Google Drive when you look for that review tracker. It has materials, responsible parties, so who is going to submit that. Then it will have criterion and also more who people responsible for that. I this year went and changed some of it to make it a little easier to understand. So this is not in Google Drive. This is just on this slideshow, but this is divided up based on who needs to submit what, whereas in the actual tracker, it's based on just each individual action item. Here, it's any engineering subteam is going to need to fill out these, systems is going to need to fill out those, basically a little more of a checklist format. There are templates and resources for some of these in Google Drive. I don't have the exact list for where they are, but for example, there is a template for DFMIAs, there's a template for trade studies, and there should be some resources for the rest of this as well. With that, I'm going to hand it over to Matthew for more information on DFMIAs.
Okay, so for DFMEAs, all subteams are required to fill this out. There is a template in the Google Drive under the Systems folder, and this just helps us understand what could go wrong with each subsystem and each design. So in case something does go wrong, we can easily mitigate anything that happens and reduce any costly effects. And this is the instructions that you'll find in the template for the DFMEAs. You can read over this if you have any questions on maybe how to fill it out. And if you can't answer your question on there, you can reach out to anyone on systems and we can help you fill it out. And then
All right, in terms of business, there isn't a whole lot of updates. I think as of now, a lot is similar to what it's been last year. In terms of budgeting, we're looking at a pretty similar numbers in terms of last year. Obviously, things may seem like they cost a lot now in terms of like the trip and stuff like that, but everything will go down over time. Every month, we're updating the budget. And in terms of funding, I'd say we're in a very good spot this year. Obviously, we have like all these plans for like building the robot and stuff, but we can't really do any of that stuff if we don't have the money to do so. We've been reaching out to all of the engineering colleges, and we have been receiving funds from them. There have been, we still have to meet, I think, with aerospace, and we're also potentially considering reaching out to honors in the future. But in terms of funding, we're in a good spot this year. We're also reaching out to some businesses, and maybe we're planning to do some sponsorships. But yeah, in terms of business, I'd say we're in a great spot. I think now it's just making sure that next year's team is in a good place as well. So. I don't know if there's any questions, but okay. Sounds good.
Okay, so that was a good SDR in my opinion. Me and Rachel are going to be working on condensing part 1, and this is part 2 on the YouTube channel, and that will be posted if you have anyone that's curious and rewatching that couldn't be here today. But yeah, refer to the schedule in the drive in terms of future meetings. As just a general announcement, next Tuesday, or this Tuesday, I guess, there's no meeting. Everyone is taking midterms in leadership, and you guys probably are too. So no meeting on Tuesday. Also, that weekend is fall break. So you guys might be traveling. I'm personally going to be out of state. So no meeting on that Saturday. But in terms of the Tuesday, as in, I don't know what day that would be. The Tuesday after fall break, or it's like the Tuesday fall break technically ends. Yeah. Okay, on the 8th, we're still planning on having a meeting if you can come. If you're still traveling that night back here to Purdue, that's okay. But I'm going to be back in town, so we're still going to have a meeting that Tuesday, even though that's technically the last day of fall break. But yeah, thank you guys so much for coming. I'm going to request that all leadership and alumni, I would appreciate if you guys were in on the leadership talk after this. If you want, it's okay if you want to leave. But yeah, this concludes SDR. Everything looks really good. Thank you guys for coming. Have a good rest of your Saturday.